So welcome to TAM Lab 98. Today's topic is VSAN Stretched Cluster, testing hardware failure scenarios. Our today's presenter is Raul, Technical Account Manager in Spain. And TAM customers, if you watch this video, please reach out to your TAM and maybe you have a great idea for a session and reach out to your TAM. And with this, Raul, I will stop sharing and hand over to you.
Okay, thank you, Tina. So let me share my screen. Okay. Okay, so today what I want, the idea about the lab is to see what happens on a VSAN Stretched Cluster when we have any hardware failure. I mean, there are many different things that can happen. So we are going to see some of them and see how VSAN is resilient and survives these events. Okay, so first of all, this is the scenario. We have, as you know, a stress cluster. It is, we have a cluster where the hosts are living on different sites. Okay, different CPDs, different data locations. Okay, we have some requirements like the connectivity for the VSAN network. It should be under 5 milliseconds. So, and what we have is a cluster with a stretched VSAN data store, where we can do vMotion from one side to the another side, to the different side, and it's completely transparent. Okay, so regarding disaster recovery, if we lose the whole site, the VMs are gonna survive on the other side. Okay, we may have situations where we have a split brain scenario. We are going to test that as well. To avoid this kind of situation, we have a witness. Usually we deploy a witness VM appliance, and that should be on a different site. And in this case, this is how is my lab. On one side, I will have the vCenter virtual machine and the witness, and then I will have two other sites with 4 ESXi hosts on each side. Okay, this connectivity between the sites and the witness for the split brain situations, it can be either layer 2. So imagine both sites are on the same building on different rooms, and they have layer 2 connectivity. So that's all right. That's a good scenario. Or we can even have the witness VM away on a completely different site, because also the latency requirements for the witness is lower. So we talk about 100 milliseconds to 100 milliseconds. It depends on the scenario. So it could be even in the cloud or anywhere else. And then we could go through a layer 3 network connecting to the witness. Okay, I'm gonna show you how is my lab. So this is my lab, it's at home. So basically what I deployed is 3 sites. One site is on a different physical host, those small Intel NUCs. So you see site C with the vCenter appliance and the witness. And then the other 2 sites, they are having 4 nested ESXi hosts. Okay, so I can test most of the things right here, because if I break the connectivity, I mean, I can just unplug the VSAN cable for one of those 2, and then I have a split brain situation where internally all the hosts have access to the VSAN. They can communicate through the VSAN network in the same site, but they cannot talk. They cannot communicate with the other room, with the other site. Okay, so this is how it looks on the vCenter. So just for the lab, just remember the 4 first hosts, 5 to 11, are site B. Then I have site A that is 9 to 12. Okay. When we create the stretch cluster for the split brain situation, we are going to define which is the preferred site and the non-preferred site. In case of a split brain situation, we only will have storage access on the preferred site. Okay, so when I do anything like a split brain, site A is going to remain with the storage access, and site B will lose that access to the VSAN data store. So we will see what happens. Okay, and then I have my VSAN witness ESXi host on site C. Then just to play with what happens with when we are breaking things, this is fun. I created some different storage policies. Okay, so I have a storage policy. Well, I have the default VSAN storage policy where I'm doing two different levels of protection. So I have the site disaster tolerance. So this is the stress cluster where I'm doing dual site mirroring. So I have data on both of the sites. And also I'm protecting locally on each side with RAID 1 with mirroring. Then I have another storage policy that I'm applying to a different VM with, again, protected across the sites and using RAID 5 Erasure coding for the protection. We will see how it looks on the web client, how we create the different components for the VM. Then I have two special policies where I'm not protecting the VM across the sites. So I'm just selecting for VSAN site A policy, I'm not doing this site disaster tolerance. So, and I keep the data on the preferred site. So that would be site A. And I protect with RAID 1 on site A. So if site A goes down, well, I'm losing access to this VM because I mean, it's not important for me. I'm not just protecting it across the sites. And I have the same for site B, another policy created for the non-preferred stress cluster where all the data is going to be kept on site B. Okay, so these are the tests I just prepared for today. Something very basic like, okay, I have two uplinks for VSAN. What happens when I lose one of the uplinks? Okay. Then I'm going to go, well, things that can happen. I mean, this is storage, this is hardware, so I can lose a capacity disk. So I'm going to unplug. I'm going to simulate that I'm going to the data center and I'm removing the wrong disk. Okay, that's something that it can happen, or it is broken or whatever. Okay, and we will see how the system is reacting and how it's self-protecting. Then I will unplug a VSAN disk, a CATS disk, and we will see how this is different because it's affecting a whole disk group. And we will see also how the system recovers. Then I'm gonna just bring down a ESXi. I'm doing a power off, simulating a hardware disaster with that host, where I don't have any VM running, but I still have a storage, okay, for VSAN. And then I will do the same with a host with the VMs running to see how HA and VSAN are working together. Next test is going to be, I'm going to take my whole site A, the preferred one, and I will lose the power. So everything is going to be power off. And we will see how things go. Okay. And the last one I prepare is the split brain scenario where I lose the connectivity between both sides, and then they have to talk with the witness and decide what to do. Okay. I left some links right here you can use for the VSAN 7 proof concept guide. Those are nice, and they have a summary of different tests we can do and how to do them, and the VSAN documentation. Okay, and then we are going to start with the lab. As you can see, don't do this on production, of course, but I really recommend you on any project to do before it goes to production. So you can see how, I mean, you can just create some test VMs and break things and really unplug servers, do things, unplug network cables, do all the kind of tests we want to document for before the project goes on production. So also we see how we are protected for those failures and how it is working. Okay, so this is the lab. I have 4 VMs, Linux 01, 02, 03, 04. Okay, and I applied different policies to them. This is a ping for those VMs. Sometimes I lose some pings. This is because this is going through PLC from wireless from my laptop. Well, it's home lab. Okay, this is where I have my physical host with the physical nested ESXIs that are doing the stress cluster. And remember, this is the first 4 are site B, and then I have site A. I'm running VMs on both sides. I have DRS rules to run 2 VMs on site A and 2 on site B. So this is going to be site B, site A, site B, site A. Linux 01 and 04 are stretched, are protected on the stress cluster. So we have components on both sides. And then Linux 02 is the storage is living on site A, and Linux 03 is living on site B. Okay. We can see, before I break anything, how we can go to the VM to monitor and check for the physical disk placement. We can see the policy. So for example, for the hard disk of this VM, I have write one protection, and also I have write one across the different sites. Okay, so then I have a local witness, and then I have the witness appliance witness for the stress cluster protection. I can see in which disk I have this component, the cache disk that it is using. I can see everything right here. Okay, and if I look to this VM, site A, it's not protected across sites. So you can see how I have a RAID 1 component, and witness, and it is on site A. And for Linux 01, we protect the VM. We have a write one across the site. So that's why I have those 2. You see how all this is on site A, all this is on site B. And locally, I'm protecting with write 5. Okay, so I'm creating a parity. And I can lose one host, and it is still protected. In this case, I can lose one host. I can lose a whole site. There are we have the extra protection for the stress cluster. So let's start breaking something. What I'm going to do first is let's check for any host. If I go to the networking for this host, I can see how my VSAN is using uplink 2. This is the VM NIC one on ESXi05. Okay, and also I have on the port group we have configured a standby uplink that is uplink 4. Okay, so I'm gonna unplug my active VSAN uplink. Okay, for host 5. Nothing should happen. I mean, we will have a transparent failover to the other uplink, and we shouldn't lose anything. The only thing I would expect is to have, I expect, because this is live, okay, I expect a warning about losing the redundancy on my port group for VSAN. Okay, let's go ahead and break something. Okay, unplug it. Okay. Right here, we see how we get the warning. Okay, if we go to the summary, network uplink redundancy lost. As you see, my VMs are still working. I have ping for every VM. This is 01, 02, 03, 04 VMs. Okay. And basically what I'm using is the other uplink. Regarding the objects, I will see that everything should be in place. Okay. Okay, I get the warning for ESXi05, but the component is still active. Okay, no big issues. Okay, so let's fix this and go for the next one. I know I started very easy, but that's why we need to have a good design for our network. So if we have a good design in our networking, everything is going to work perfectly. Okay, so next thing I want to do is, okay, I'm going to bring a capacity disk down. Okay, so first let's go to, I'm going to unplug a disk on ESXi 10. So real life, that would be somebody unplugging physically the disk. Okay, it could be a broken disk, it could be something like that. Okay, so if I go to the stress cluster, I go to monitor, and I go to physical disk under the VSAN section, I have information right here for every disk on my disk group. In my home lab, I only have one disk group. Ideally, I would like to have two. I have resources. So I can see how I have a CAT disk. Okay, you see how we don't use capacity on the CAT. And then for the capacity disk, I have three, two 20 gig disks and one 8 gig disk. Okay, on specifically this disk, I have 4 gigs use. Okay, and I'm going to unplug it. This is going to affect to, this is very nice. If I see the physical disk right here, I can see which objects are having components on that physical disk. So this is going to affect to the Linux 01 VM, Linux 04, also to the cluster services VMs. So I'm gonna see if it breaks something. Okay, so let's unplug the disk. Okay, unplug it. Let's see. Well, so far my VMs are all right. Okay, I have connectivity to all of them. Okay, let's reload. Let's look for my ESXi 10 right here. Okay, so you have we see how now my disk is absent. Okay, so it is an unplug, so I can replug it. And what is going to happen is right now, when it comes back, I will have stale components. So that would be, I have the component, but it's not up to date. Okay, it is going to check the component, the configuration serial number on both on the component, and it's going to check, it's going to see that it is old and needs to be updated. So I'm going to it is going to resynchronize the data and it will be back to active. Okay, so let me, well, we can see also Linux 05 was affected. Okay, so I can go to the VM as well, check for the physical displacement and see how I have an absent component. And hey, this is something that we have new from the new versions, that in order to have a faster resynchronization, we are creating a durability component. So this on this component that we created, we are making all the new writes. So as soon as our component is back, it is going to send these writes that we are storing on the durability component to the original component that is that was absent and it was out of date, and it's going to we are making a faster resynchronization with the durability component. So whenever we have resources to create it, it's going to create it maybe on a different disk on the same host, or even on on another host, and then it's going to do a direct resynchronization with all the new input, all the new writes that happened during the absent time to the original component that was stale. Okay, so let's replug the disk.
While you're doing that, Raul, how are you simulating plugging the disks out? Because they're nested up.
So for this, for the disk unplugging, we have a script on the ESXi. So by default, we have a script on the ESXi. And we have different options to unplug or make a failure of the disk, permanent failure. And then we have options for fixing it and all these kind of tests. So on the link for the concept, for the proof concept that I left, we have the instructions on how to simulate this. Okay, because of course it is a nested ESXi, I cannot unplug anything. Okay.
Thank you.
You're welcome. And thank you for talking, because I was about saying, hey, can anybody talk? Because I don't know if I am alone. Okay, so I replugged it. And okay, everything is back. So it is very fast because these are small VMs, even if I have a very bad hardware on my lab, but the resynchronization is really fast. And for on each version, we are making better resynchronization and pushing on that. So we survived to the disk failure. Okay, I still have some alerts right here, but probably if I go to my cluster, to the Skyline Health, and I do a retest, it should be all right. Okay, yes, everything is green. My objects are back to compliance. So, okay, so also I can go to any VM and check for the VM storage policy and if it is compliant.
Oh,
okay.
we have a question. Does VSAN detect disk failures based on SCSI sense codes sent by EXI kernel, or does unplug differ a lot from a compared actual failure?
Yeah, does VSAN detect disk failures
okay.
sense codes from the ESXi kernel? Does it differ from compared to an actual disk failure?
Yes, of course, it does, because I'm plugging. You see how when I unplug, the disk appears as absent, and the components that I had on the disk, they appear as absent. So if they are absent, let me show you on the VSAN Stretched Cluster configuration. Okay, let's go to configure Stretched Cluster VSAN services. Okay, and what is happening is you can see the advanced options. We have the object repair timer, 60 minutes. That's the default. I can change it to anything I want. Okay. What happens is if it is absent, we wait for 60 minutes in this case. And if it's not back, because if it is absent, it can be back. I'm going to trigger a resynchronization. I'm going to create a new component on an on a different resource, and I will remove that. Well, if it comes back after I rebuild, I will discard the component. Okay, so if it is broken, it is going to be degraded. It's not going to be absent. Okay, and the resynchronization is going to start at the moment. So the difference is I will create a new component on a different disk in my disk group in order to be compliant again, because I'm not expecting a broken disk to come back. Okay, so through the SCSI codes, yeah, we see that it is an unplug, and that makes sense when we have in our servers, we have a hot plug disks. Okay. I'm going to break a catch disk. This is more, yeah, it's harder for the system, because what happens is, let's go to monitor again, the physical disk. Okay, and I will break again on host 10. I'm going to break this 4 gig disk that is the catch. You see, we don't have capacity right here because it is only used for, this is a all-flash environment. So I'm doing, we are doing write buffering. All the writes are first done on this disk, and then the system is moving them to the capacity disk. So if I lose the catch disk, I cannot be sure that we have integrity, that everything, every data that we wrote was moved down to the disk group capacity disk. So what happens is that I'm going to stop the whole disk group. This is going to be a problem in my scenario because I only have one disk group. In other scenarios, I would have, if I have more than one disk group, well, I'm more resilient because I'm not losing the whole storage on this host. Okay, so let's break it. I'm just unplugging it again. Okay, and we will see how now it is just marking all my disk on the disk groups as absent. Okay, so you see even the broken disk, or not broken in this case, unplugged disk is the catch. Okay, all my disk on the disk group are absent. So now this is going to affect more components. I can check any VM and probably is affected by this failure. Okay, so I have on my Linux 01 stretched write one VM, I have an absent component. I created a durability component on a different host, I11. Okay. For that VM, again, that is only on site A, I have an absent component. Again, I created a durability component. This VM is not affected. Why? Because it is just living on site B. It's not protected across sites. Okay, this one should be definitely affected. Okay. And I don't have any resources for creating the durability component because I lost the whole disk group. So, okay. But everything keeps going. I mean, I'm not compliant. If I go to the VM, it should not be compliant. Okay, right here, storage policy compliant. It's not compliant because it's not protected with write. It's not fully protected on site A. Okay, I'm missing storage group. I'm missing a host. I don't have this component. Okay. And I'm going to replug the disk and see how everything comes back to normality. Okay. So this is really fast. See, this is right back. I could see if this is still resizing anything, but it's too fast because I don't have too much data. Okay. Next thing I break something, we will come right here and see what is left for resizing. The next thing I'm going to do is bring down a host. Okay, a host where I don't have any VM running. So let's take a look which one I can bring down. Okay, so ESXi 5, I don't have any VM running right here. Okay, I could just reboot, or I'm going to do a hard shutdown of the nested VM. Okay, so I don't expect any change on my VMs because no VM is running right here on ESXi 5. I will keep the ping for all of them. What I'm losing is components. Okay, I start getting warnings. Okay, why? Because I'm not able to communicate. My VSAN cluster is saying, hey, where is host 5? I cannot reach it. Okay, and if I go to my VMs, I can see monitor, physical disk placement. I can see how there is no component. The component on host 5 is absent. Okay, right here. And I created a durability, the system created a durability component on another host on the same cluster, on the same, site. Okay, so it is absent because we have 60 minutes until it comes back. Okay, if I change that, what is going to happen? Let's say I change the timer from 60 to 1 minute. After 1 minute, we should see how there should be a new component created to replace the absent one. Okay, and that would be the same if it is broken. Okay, if it's a broken component, a broken hard disk, it would happen the same. We do what they call auto healing, self healing. Okay. Anyway, there is no impact on the VMs because we have, in this case, double protection. So it is still reachable on site B. Okay, but also if something else happens on those hosts, I have all my copies on site A active, so the VM is will still work. Okay, let's bring back the. Oh, okay. I said I would check for the stress cluster. Okay. Resizing objects. So all these objects are marked for resign. Okay. So it's affecting mostly all my VMs except the one that is only living on site A. Okay, let's bring this back because if not, I won't have enough time. Okay, and it's gonna take some minutes until it's back and running. And on the meantime, we can check what is happening. One thing that is nice is that we can see how I'm going to open a console for host 5 that now is booting. And we will see that even the host, when the host is not reconnected to the vCenter, as soon as the vSAN service is back, it is going to trigger the resynchronization. So when the host is back, in this scenario, is going to be back and running, up and running. Okay, so we see how vSAN is now doing the recovery. Even the host is not really connected to the vCenter, but remember, this is a cluster service, so we don't really need the vCenter in order to have vSAN running. vCenter could be down, or we could be upgrading it. Doesn't matter because the cluster is working independently. And if I go right here, soon I will be that my component is back right here. Even if the host is not connected to the vCenter, but my component is reachable, is back, it's up and running. Okay, let's see if, okay, now it should reconnect to the vCenter and we should get out of warnings and errors. Okay, so I'm going to do the same with host number 8 that is running the stretch VM. So what is going to happen now is, well, we have vSAN and also we have vSphere, we have HA. So if I reboot this host or I power off this host, okay, so simply HA is going to power on the VM on a different host because still we have the vSAN protection, so the other host has access to the storage. Okay, so this is Linux 01. Okay, it's gone. What I did is power off this host with the VM running. So I lost the VM and it should just power on a different host. And this is exactly the same that it would happen with any other storage, with any other shared storage. Okay, let's take a look. The VM. So hopefully sooner or later it's come back on a different host. Okay, so it's back. Hopefully it worked. Now it's on ESXi 05 and my host is powering on number 8. So I have time to do the next test. So I'm gonna bring the whole site down, okay? And let's see what's happened. Well, at the moment, host number 8 is down, okay? So I will have an absent component. Not on this one, but on maybe on. Yep, right here. What I'm going to do now is bring down the whole site B. Okay. So my 4 VMs are running. I'm going to lose the whole site. And well, there will be one VM not surviving, of course. That is 03, because that VM is just running on, it's not protected with the stress cluster. Okay, so the policy that we apply to Linux 03 is VSAN site B. So we only store data on site B. Okay, also the Linux 01 was running on host 6. Well, so it's down, but I should expect this VM coming back because HA will power on the VM on the different site, on site A. Okay, so Linux 03 not coming back, Linux 01 again. Should come back this time on site A. And if we look to the physical displacement for any VM now, is going to look very different because we lost the whole site. Okay, so we can see how everything on site B is absent. We lost it. Okay, for this VM, everything was on site B, so there is no solution. It's not critical for us. We left it like that. We could just right-click, change the policy when everything is all right again. Change the policy and protect that VM across sites. So next time we don't lose it. I mean, if somebody says, "Hey, that VM was maybe more critical than we thought," we need to protect the VM if a site goes down. Just right-click, we change the policy, and it creates the new components, and it's already protected. No time down. Okay. So in the meantime, I'm going to power on. Okay, so Linux 01 coming back. And if we take a look now, it should be on site A. Yeah, it just jumped with HA to the surviving site. Okay. Now I'm powering on again the whole site, site B. When it is back, we will check the split brain situation. By the way, this VM that is only on site B, when the host on site B come back, it should be powered on by HA.
Following on from the question I asked earlier on, if people wanted to do these tests on their own labs, do you have the code available for those scripts that you can release, or is it internal?
Sure. So it is right. Well, on the links I left, right here.
Okay, so the code to take down the disk, for example, is in that resource guide, are they?
Yeah. Right here, we have a section on this proof of concept guide with the testing hardware failures, with the different failure scenarios. Right here, we have the disk failures, and we can see how we can simulate this right with this script that we have on the ESXi host. So we don't have to, it is already there on our ESXi host. And we just need to execute this Python a script with the different options with plug, unplug, inject transient error, permanent error, clear, and we can simulate that on. Okay.
I do have another question, but it's a longer one. Do you want me to ask it now, or do you want to wait till the end?
Well, it's all right now.
Okay. Well, you've covered some pretty cool scenarios there, and I think given everyone a lot more confidence in showing us how to play around with VSAN in our labs and just how resilient it can be. But I'm going to take an edge case scenario with you. Now, we've always take our internal power and the grid for granted, and we have UPSs and maybe building generators. But for, say, in the case of a natural disaster, where in areas where power is not quite so resilient, or in mobile cases where you've got generators powering your hardware, take the example where site A goes down, and then site B takes over. Site B goes down, but then site A comes back up again and with stale data. Now, in that scenario, say, for example, it might be an emergency service or something critical, and you're not that worried about loss of data, but you want site A to come back live, but it's got stale data on. What can you do in that scenario? Does that make sense?
Okay, yeah. So that would be time for our support team. In fact, they have utility. So they have a tool for fixing this kind of a scenario where they can recover the components from a stale component. Okay, but this is not public available. Basically, we should be sure that site B is not coming back. Okay, so we have site A power on with the stale data. We call support, or we open a priority one, I guess, case, and they have this tool. And I've seen the tool. I have seen the documentation. The first thing the documentation says is that only engineers who did a specific training should use that tool. Okay, but they have the training. They have the engineers that have passed this training, and they can recover stale data and create recover those objects. Okay. Of course, you cannot ensure 100% integrity but usually it works.
Okay, thanks. And site B must never come back up after that.
Yeah. Well, actually, what I think is they recover the objects, and they can even create a new object. So you have the new version of the object that is decoupled of the old version. Okay, so you can mount your VMs with that information recovered.
You don't have to rebuild site B. You can recover that as well.
Yeah.
Good to know. Because that's probably the worst scenario I can think of.
Yeah, and of course you need enough space for recovering all this, but yeah, it's a very bad scenario.
Anything else you want to add at this moment for the attendees who are still with us? Well,
I think you see how my VSAN Stretched Cluster is surviving to all this beating up. So, and it's been a hard month for my lab, and it's still up and running. So imagine if you have, the proper hardware. I mean, this is solid rock. I mean.
Okay, well, certainly that's been absolutely fascinating. I've really enjoyed that, Raul. Thank you. And I think I can see just how much effort and planning went into making it ready to deliver in such a slick fashion. So thank you very much indeed for taking the time to do that and showing us what you know. And thank you everyone else for taking the time to show up. Please take the time to fill in the survey. And also, please, when the link comes out, forward it to your customers and share and come and present on TAM Lab. Thank you, Raul, and thank you, everyone.